This call is now being recorded.
Whether my screen is visible to you?
Yes, sir.
Okay, guys. Today we are going to enter into the Unit 4. In Unit 4, we are going to discuss about engine management system. So today we are going to getting to know your engine management system. So the engine management system and automotive engine control actuators and the electronic fuel injection system and digital engine control system and car navigation and advanced telematic system and exhaust gas recirculation system. Now let us enter into the engine management system. Okay, nowadays most of the cars, not most of the cars, almost 99.99% cars, uh, every car is equipped with a ECU, electronic control unit. So this electronic control unit is going to play a major role to control the activities which is carried in the engine, all automotive vehicles. So the all functioning is going to monitor, and whenever is there any change or anything is required to change, so this electronic control unit is going to give some commands or order to the actuators, so that will control the functioning of the cars. Okay, so in the engine management system is one of the smartest system in today's vehicle. Is it right? Because this will control each and everything in your car or in your all automotive vehicles. Okay, the smartest system. So this will control everything in your car or vehicle. And after all, it is responsible the entire combustion process and mixing the right amount of air fuel ratio or proportion entering the engine, and as well as it will ignite. It will also give some comments, or it will also monitoring the igniting the compressed air fuel mixer in the cylinder at right time, right place. Next is more than earning its reputation as the brains of the car. In fact, the engine management system is where traditionally the most advanced vehicle technologies are found, operating 30 plus components approximately. Operating 30 plus components and approximately 50 computer modules to deliver the millions of lines of code that keeps the vehicle running efficiently. Okay, so but what exactly is the engine management system? And here we take a closer look at the engine management components and the important role that each of them plays. The engine control unit. So that is easy. Engine control unit. This will controlling the engine. Okay, this will controlling the engine is the most processor intensive job or any car, and that is all down to the engine control unit. So more commonly known as the ECU, electronic control unit, or PCM, program control module, or program control device, something else. So using the data, it receives the using the data it receives from the multiple sensors or multitude of sensors located in the different areas of the engine. The electronic control unit knows everything there is to know about the engine. Okay, ஒரு ஹியூமன் பீயிங் தெரிஞ்சுக்கிறத விட, நம்ம ஒரு டிரைவர்ஸ் தெரிஞ்சுக்கிறத விட, இந்த என்ஜின் எலக்ட்ரானிக் கண்ட்ரோல் யூனிட் வந்து பார்த்தீங்கன்னா, ஸோ தி எலக்ட்ரானிக் கண்ட்ரோல் யூனிட் வில் நோ ஈச் அண்ட் எவ்ரி திங் அபவுட் த என்ஜின் அண்ட் த பர்ஃபார்மன்ஸ் ஆஃப் த என்ஜின் as well as என்ஜின் எந்த மாதிரி ரன் ஆகிட்டு இருக்குது, எவ்வளோ ஃபியூல் அனுப்பணும், எவ்வளோ லோடு ஆக்ட் ஆகிட்டு இருக்கு, எவ்வளோ ஸ்பீடு போகிறாங்க, எவ்வளோ அனுப்பணும் அப்படிங்கிறது எல்லாமே ஃப்ராக்ஷன் ஆஃப் செகண்டில் டிசைட் பண்ணி அனுப்பிச்சிட்ருக்கோம். ஸோ கண்டினியூஸாக மானிட்டர் பண்ணிகிட்டே இருக்கும். எந்த ஒரு ப்ராப்ளமும் இருக்காது. இப்போ இருக்கிற வெஹிக்கிள்ஸ் எல்லாமே அந்த மாதிரி தான் இருக்குது. எல்லா வெஹிக்கிள்ஸுமே வந்து பார்த்தீங்க அப்படின்னா இசியூவோட தான் இருக்குது. இசியூ தான் இன்ஜினையே ஆப்ரேட் பண்ணுது. எவ்வளோ ஃப்ளோ, எவ்வளோ ஏர் ஃப்ளோ இருக்கணும், எவ்வளோ எந்த டைமில் இக்னைட் பண்ணணும், என்ன பண்ணணும், எது பண்ணணும், எவ்ரி திங் is loaded in ECU, electronic control unit. Electronic control unit is nothing but CPU, like central processing unit, like in our computer. So this will store the lot of programs. Okay, that is developed by the R&D department. அவ்வளோதான் அதில் வேற ஒன்றும் இல்லை. So from the speed and temperature, this will also monitor the speed and temperature of the intake air to the amount of oxygen in the exhaust. It then processes this data, performing millions of calculations every seconds. ஓகேங்களா, to determine how each sensor should respond in order to achieve the very best engine performance, emissions, and fuel economy. So these are all the important points of the EC electronic control unit. This will play a major role in the automotive vehicles. Okay. We discussed the all type of sensors and working in the earlier classes. That means previous units. We discussed everything. Okay, this engine management system is going to represented in this picture by the standard of three-stage model. Okay, one is input sensor, then ECU, then finally, so we will have a output actuators. இதையே தான் நம்ம பார்த்துட்டு இருக்கிறோம். எல்லாத்துலேயுமே வந்து பார்த்தீங்கன்னா சென்சார் வந்து மானிட்டர் பண்ணி என்ன பண்ணிட்டு இருக்கு, அந்த காம்பனண்ட் என்ன பண்ணுது, இந்த காம்பனண்ட் என்ன பண்ணுது, என்ஜின் எப்படி ஒர்க் ஆகுது, ஏசி எப்படி ஒர்க் ஆகுது, மழை வர்ற மாதிரி இருக்கா, ரெயின் ட்ராப் விழுந்திருக்கா, எல்லாமே வந்து எல்லா டேட்டாவையுமே கலெக்ட் பண்ணி மில்லியன்ஸ் ஆஃப் டேட்டா இன் மில்லி செகண்ட்ஸில் வந்து அனுப்பிச்சிட்டே இருக்கும். ஓகேங்களா, அந்த டேட்டா வந்து ECU ரிசீவ் பண்ணும். ECU ரிசீவ் பண்ணிட்டு இன்கேஸ் ஏதாவது சேஞ்சஸ் பண்ணணும்னா ECU கமெண்ட்ஸ் கொடுக்கும் அவுட்புட் ஆக்சுவேட்டர்ஸ்க்கு. தட் மீன்ஸ் இந்த அவுட்புட் ஆக்சுவேட்டர்ங்கிறது ஒன்றும் இல்லை, என்னென்ன காம்பனண்ட் என்ன வேலையை செஞ்சுட்டு இருக்குதோ அது ஆக்சுவேட்டர்ஸ். ஸோ அது வேலையில் ஏதாவது மாறுபாடு இல்லை வித்தியாசம் இருந்துச்சு அப்படின்னா, so this actuators, the EC electronic control unit will give commands to the actuators to rectify the errors or anything working in wrong mode. அதை வந்து கரெக்ட் பண்ணி. So the representation shows the closed loop feedback, as I said many times earlier. So the closed loop control system, so which is a common feature in nowadays. Most of the cars are equipped with a closed loop control system. Okay, without closed loop control systems, if you have the ECU or any type of car, so definitely, so you will not run your engine with more efficiency or with more effectively, because this electronic control, the unit with the closed loop control system is going to have a more efficient than other type of control unit and module, because then and there or immediately in a millisecond or fraction of seconds, so we will get a feedback if any component or any actuator is going to working in a wrong mode. அதுக்காக யூஸ் பண்ணுறோம். So lambda control, knock, ideal speed and everything. So this general block diagram of an ignition and fuel control system. இந்த என்ஜின் மேனேஜ்மெண்ட் சிஸ்டம் வந்து பார்த்தீங்கன்னா, ஸோ லெஃப்ட் சைடில் சென்சார்ஸ் எல்லாமே இருக்கும், ரைட் சைடில் ஆக்சுவேட்டர்ஸ் இருக்கும். இந்த சென்சார்ஸ் பார்த்தீங்கன்னா, ஃபார் எக்ஸாம்பிள் ஸ்பீடை வந்து மானிட்டர் பண்ணுது. ஸ்பீடு வந்து வீல் வந்து ரொட்டேட் ஆகிட்டு இருக்கும்போது அதனோட ஸ்பீடு, அதே மாதிரி ஃப்ளை வீல் ரொட்டேட் ஆகும்போது கிராங்கோட ஸ்பீடு எல்லாத்தையுமே வந்து மானிட்டர் பண்ணலாம். இதில் என்ஜினோட ஸ்பீடு வந்து எவ்வளோ அப்படிங்கிறது, ஸோ வி வில் மானிட்டர் வித் ஹெல்ப் ஆஃப் த சென்சார். தென் என்ஜின் லோட், engine temperature and voltage. தென் ரைட் சைடில் வந்து பார்த்தீங்கன்னா இக்னிஷன் அண்ட் ஃபியூல். ஓகேங்களா, ஒன்று வந்து ஒரு சைடில் என்ஜின் ஸ்பீட் இருக்கும், என்ஜின் லோட் இருக்கும், என்ஜின் டெம்பரேச்சர் as well as voltage. Then depends upon the engine speed and load, so we need to ignite accordingly, as well as depends upon the speed and load conditions, we need to change the air fuel mixture ratio, okay, in a proper proportion. So that is very much essential every vehicle in automotive system. And these are all the parts. You just look into these parts. The left side is the sensors, different types of sensor, and right side is actuators. In center, this is a microcontroller for engine management system, but nowadays we are using a microprocessors. Okay, nowadays we are having a microprocessor. Okay, in this the left side you can see the different types of sensor is going to attach with the the engine and in and around of the cars to monitor the functioning of the car or any kind of automotive vehicles. Okay, so here the many of the sensor is related to the IC engines. So this is going to monitor the IC engines. So that is mentioned in this picture. So you can see the different types of sensors. இந்த லெஃப்ட் சைடில் இருக்கிற சென்சார்ஸ் பார்த்தீங்க அப்படின்னா ஸோ மோஸ்ட் ஆஃப் த சென்சார்ஸ் விச் இஸ் யூஸ் இன் ஒன்லி ஐசி என்ஜின்ஸ். ஐசி என்ஜின்ஸில் மட்டும்தான் இந்த மாதிரி சென்சார் யூஸ் பண்ணுறாங்க. லெஃப்ட் சைடில் இருக்கிறது எல்லாமே ஓகேங்களா. ரைட் சைடில் இருக்கிறது எல்லாமே வந்து பார்த்தீங்கன்னா அது ஆக்சுவேட்டர்ஸ் ஐசி என்ஜின்ஸில் இருக்கிறது மட்டும்தான். பட் அது போக இது இல்லாமல் நிறைய சென்சார் இருக்குது, அதையும் ஈஸியாக வந்து கண்ட்ரோல் பண்ணணும். ஓகே, இந்த பிக்சரில் காமிச்சிருக்கிறது வந்து பார்த்தீங்கன்னா ஒன்லி இட் இஸ் ரிலேட்டட் டு த என்ஜின் ஃபங்க்ஷனிங் அப்படிங்கிறது அது காமிக்குது. என்ஜின் ஸ்பீட் சென்சார் இருக்குது லெஃப்ட் சைடில், தென் டெம்பரேச்சர் சென்சார் இருக்குது, த்ரோட்டில் பொசிஷன், மாஸ் ஃப்ளோ ஏர் சென்சார், ஆக்சிஜன் சென்சார், நாக் சென்சார், ஆயில் ப்ரெஷர் சென்சார், ஃபியூவல் ப்ரெஷர் சென்சார், தென் அனலாக் இன்புட்ஸ், தென் அனலாக் அவுட்புட்ஸ், தென் மேலே வந்து பார்த்தீங்கன்னா வோல்டேஜ் ரெகுலேட்டர். வோல்டேஜ் ரெகுலேட்டர் இல்லாமல் எக்ஸஸ் வோல்டேஜ் போச்சுன்னா ஈஸி ஃபால்ட் ஆகி ஃபெயிலியர் ஆச்சுன்னா டோட்டலாக உங்கள் கார் அதே இடத்துல உட்காந்துக்கும். ஓகே, அதுக்காக வோல்டேஜ் கான்ஸ்டன்ட் வோல்டேஜ் வந்து அதில் போயிட்டு இருக்கணும். தென் இக்னிஷன் காயில் டிரைவர்ஸ், ஃபியூல் இன்ஜெக்டர் டிரைவர்ஸ், சொலினாய்ட் டிரைவர்ஸ், டேட்டா பஸ் டிரைவர்ஸ். ஸோ என்ன மாதிரி ஒர்க் ஆகுங்கிறத இந்த லெஃப்ட் சைடில் இருக்கிற சென்சார்ஸ் எல்லாமே மானிட்டர் பண்ணிக்கிட்டே இருக்கும் எல்லாமே. பிகாஸ் இது வந்து க்ளோஸ் லூப் கண்ட்ரோல் சிஸ்டம், ப்ரீவியஸ் டயக்ராமில் பார்த்த மாதிரி மானிட்டர் பண்ணி டேட்டாவை அனுப்பிச்சிட்டே இருக்கும். தென் டேட்டா ஈஸியில் ஸ்டோர் ஆகிட்டு இருக்கிற ப்ரோக்ராமோட டேட்டாவும் ரெண்டு சேமாக இருந்துச்சுன்னா நோ ப்ராப்ளம், நோ சேஞ்ச் வில் பி ஹேப்பன். இன்கேஸ் எனி சேஞ்சஸ் இருந்துச்சு அப்படின்னா ECU வந்து கமெண்ட்ஸ் வந்து கொடுக்கும். ஃபார் எக்ஸாம்பிள் என்ஜினோட ஸ்பீட் அதிகமாச்சா, ECU சென்ஸ் பண்ணி ஸ்பீட் அதிகமாக போகுது அப்படிங்க உடனே கமெண்ட்ஸ் ECU வந்து பார்த்தீங்கன்னா ஃபியூல் இன்ஜெக்டருக்கும் இக்னிஷன் காயிலுக்கும் அது கமெண்ட்ஸ் கொடுக்கும். கொஞ்சம் ஃபியூல் சேர்த்து அனுப்புங்க, அதே மாதிரி இக்னிஷன் கொஞ்சம் ஜாஸ்தி பண்ணுங்கள், ப்ரொபோர்ஷன் ரேஷியோ மாற்றுங்க, தம்பி ஸ்பீடாக போயிட்டுருங்களா அப்படிங்கிற மாதிரி. அதே மாதிரி லோடு அதிகமாக வச்சு போகிறோம், இன்னும் கொஞ்சம் ஃபியூலை சேர்த்து அனுப்புங்க, தனியாக தான் போகிறோம், வெயிட் கம்மியாக தான் இருக்குது, ஸோ கம்மியான ஃபியூல் அனுப்புங்க. இந்த மாதிரி எக்ஸாம்பிளுக்கு நான் சொல்கிறேன். இந்த மாதிரி தான் வந்து பார்த்தீங்கன்னா கமெண்ட்ஸ் வந்து போயிட்டுருக்கும். ஓகேங்களா. ஸோ இதில் ஒவ்வொரு சென்சாரை பற்றி நம்ம பார்த்துருக்கோம். ஆக்சிஜன் சென்சார்னா இது வந்து ஆக்சிஜன்ஸ் லெவல், எக்ஸாஸ்ட் எவ்வளோ இருக்குது, இன்ஜின் எமிட் ஆகும்போது எவ்வளோ எக்ஸாஸ்டில் இருக்குது அப்படின்னு சொல்லி பார்ப்போம். ஸோ அதுக்கு தகுந்த மாதிரி ஸோ வி கேன் ஃபைன் டியூன் த ஏர் ஃபியூல் ரேஷியோ டு ரெடியூஸ் த எமிஷன்ஸ். சரிங்களா. அதுக்கப்புறம் கூலன் டெம்பரேச்சர் சென்சார். இது வந்து பார்த்தீங்கன்னா இது வந்து என்ஜின் இட் வில் மெஷர் த என்ஜின் டெம்பரேச்சர் டு மானிட்டர் ரேஞ்ச் ஆஃப் ஃபியூவல், ignition and emission control function. Next mass flow air sensor, இது MAF சொல்லுவோம். So this will monitors how much air is entering the system to determine the required fuel mixture. And next is manifold absolute pressure sensor. This is shortly called as MAP, and this will records intake vacuum for accurate ignition timing and fuel delivery. And next is throttle position sensor. So this will determines the positions of the gas pedal to adjust the spark timing and fuel mixture in line with the changes in engine load. Camshaft sensor measure camshaft speed and the resultant position of each piston to the control ignition and fuel injection timing. அதே மாதிரி crankshaft sensor measures the engine RPM to determine the relative position of the crankshaft for controlled spark timing and fuel delivery. நாக் சென்சார்ஸ், இப்போ என்ஜின் எல்லாம் பட்டு பட்டுன்னு சவுண்ட் வரும், ஸோ அந்த மாதிரி சவுண்ட் வந்துச்சுன்னா இமீடியட்டாக டிடெக்ட் பண்ணிடும். நாக் சென்சார்ஸ் டிடெக்ட்ஸ் என்ஜின் நாக்கிங் அண்ட் சப்சிக்வெண்ட்லி ரிட்டார்ட்ஸ் டைமிங் while the engine is under load to protect the engine against spark knock. எக்ஸாஸ்ட் கேஸ் டெம்பரேச்சர், எக்ஸாஸ்ட் கேஸில் எவ்வளோ டெம்பரேச்சர் போயிட்டு இருக்கு அப்படிங்கிறத மானிட்டர் பண்ணுறதுக்கு எக்ஸாஸ்ட் கேஸ் சென்சார். So protects the components exposed to the flow of hot exhaust gas from overheating by instructing the ECU to lower the temperature. Also establish the optimum temperature for the regeneration diesel vehicle. Next one is ABS sensor. Monitors the wheel speed to prevent the brakes from locking and avoid uncontrolled skidding. Sensor transmission speed sensor calculates which gears the transmission should engage for efficient driving. Oil pressure sensor monitors engine oil pressure levels and activates oil warning light whenever required. Okay, இந்த மாதிரி நிறைய வந்து இதில் இருக்கு.
Hello viewers. Let's talk about engine control module and its requirement in vehicles. Basically, engine control module is known as powertrain control module or engine control unit. So what the ECM does? The main function of this controller is to get information from sensors and run certain actuator. The vehicle computer uses these inputs to adjust its settings so the vehicle can run in accordance with your driving habit. Let's know about the connecting sensors, which are playing the important role in ECM. Engine coolant temperature sensor, air temperature sensor, manifold absolute pressure sensor, mass airflow sensor, idle air controller, crankshaft sensor, camshaft sensor, throttle position sensor, oxygen sensor, NOx sensor, engine coolant temperature sensor. Its function is to instruct radiator fan to turn on and cooling down the liquid after getting temperature above 75 degrees. It is usually located at the bottom of radiator or top radiator hose towards engine block. Air temperature sensor. Air temperature sensor monitors the temperature of air entering into engine. The ECM needs this information to estimate the air density and can prepare a balanced air mixture. It is usually located in air filter box or pipe that is attached to the air filter box. Manifold absolute pressure sensor. This sensor is a key sensor because it senses the engine load. This sensor measures air pressure, which tells ECM the current altitude of the vehicle. With the help of this information, ECM can adjust the ignition timing and fuel enhancement. It is bolted on the intake manifold or linked with a vacuum pipe from intake manifold. Mass airflow sensor. This type of sensor measures the volume of air entering into engine. Actually, this information helps the ECM to balance and deliver the correct fuel mass to the engine. It produces more current to keep temperature required by the manufacturer. It is located on air cleaner box. Idle air controller. It works to keep RPM of engine steady. It is an actuator, not a sensor. It increases the RPM of car until the coolant temperature sensor indicates the high engine temperature. Crankshaft sensor. It monitors the position and rotational speed of crankshaft, and this information is important for ECM to control ignition system timing. Camshaft sensor. It is an electromagnetic sensor which produces voltage when a metal object moves past it. The sensor contacts with ECM for position of camshaft. It is fixed at the end of camshaft. Throttle position sensor. This sensor is linked with accelerator pedal, and the throttle body sends information about injector pulse width and spark timing. It is located in throttle body and it is neither washable nor repairable. Oxygen sensor. It measures the proportion of oxygen in fuel and the amount of fuel consumed by the engine. There are two types of oxygen sensors. One is zirconia and another one is titania. NOx sensor. This sensor contains a crystal that detects mechanical stress and produces a voltage when the car knocks. It also allows different grade fuel without any type of engine problem, and it is fixed in engine body. These are the sensor details. But question is, what happens when any sensor fails? Well, sometimes sensors simply don't work. So don't forget to repair it. Make sure to repair it or replace it with a new one for better performance. Have a safe drive. Thank you. Hello viewers. Hello
Yes, I think you have a better understanding of that electronic control unit module and where it is located and how it is working. So I think you have seen all that this picture indicates a Volvo engine and the feature of the inlet manifold design. Okay, and this is the variable valve timing picture. because in four-stroke IC engines we have two valve. One is inlet valve and another one is outlet valve. In inlet valve, so what is happening in inlet valve during the suction stroke? So the air fuel mixture is going to enter into the cylinder, and after that, the compression stroke, the inlet and exhaust both valve is going to in a closed condition. And next, the power or expansion stroke also the valve positions are in the same condition. And in exhaust stroke, the exhaust valve, that is the outlet valve is going to open to send the burned gases, so that is emission is going to out from the combustion chamber. So this is what happened in IC engines. So the inlet valve will be open only during the time of air fuel intake into the combustion chamber. Okay. So here the variable valve timing, so you can see the Honda's valve control systems. So the here in this system, the 12 valves control the mixture and combustion of air and fuel. This deliver maximum efficiency with the lowest possible emissions. And during the engine highest speeds, the hydraulic pins is going to activate the extra valves to give 16 valve performance. So because depends upon the n number of cylinders what we are going to using in our IC engines, so the valve is going to be located for each and every. And it's not related to
Hi
ours.
there. Have you heard about the recent technology incorporated in automotive sector? Well, that is called EMS Engine Management System. EMS is a type of electronic control unit that controls the running of an engine by monitoring the engine speed and ensure optimal engine performance. Technically, the engine management system is responsible for controlling the amount of fuel being injected and for adjusting the ignition timing. Here, optimum functioning of the EMS assures maximum engine power, with the lowest amount of exhaust emissions and the lowest fuel consumption. It means it measures the exact quantity of fuel required to start an engine. Why car need an engine management system? Actually, it is required to manage the powertrain inside the engine. And it also helps to maintain proper coordination with an engine's ignition system, fuel injection system, and emission control. In short, it helps to maintain a right coordination within the engine parts so that it will give better output. Let's discuss about the key parts. They are electronic fuel injection system, air induction system, fuel delivery system, electronic control system, electronic control unit, fuel injector sequential, airflow sensor, air temperature sensor, throttle position sensor, temperature sensor, oxygen sensor, idle air control valve, MAP sensor, NOx sensor, engine speed sensor, engine oil sensor, crankshaft sensor, camshaft sensor, and multi-point fuel injection. First, electronic fuel injection system. This is the primary fuel delivery system which determines the amount of fuel to be injected into the engine and when to fire the spark plugs. This information helps the engine to achieve the most horsepower with the least amount of fuel. Air induction system. The purpose of the air induction system is to filter, meter, and measure and take airflow into the engine. Fuel delivery system. It helps to inject the correct and precise amount of fuel in the intake manifold. It measures the exact fuel efficiency, emission performance, and engine tuning, etc. Electronic control system. The purpose of electronic control system is to detect air temperature, engine temperature, throttle valve opening angle, amount of air entering to air induction system, etc. The system controls the correct amount of fuel to be injected and the proper time at which the fuel will be injected at any speed and load condition. Electronic control unit. The electronic control unit serves as the control center for all of the sensors on a car. It controls more than one electric system and subsystems in a motor vehicle. That's why it helps in regulating and maintaining the amount of fuel and air that is needed by engine to increase horsepower. Fuel injector sequential.
It's a type of multi-port injection system in which injection valve will open just before the cylinder intake valve opens. It has the fast response time when the driver makes a quick change at the time of driving. Airflow sensor. An airflow sensor is a device that measures the actual speed of the air flowing through the engine in different segments. Generally, it measures the mass of air flowing through the device per unit of time. Air temperature sensor. Actually, it helps to measure the air density for fuel mixture control and to trim the airflow ratio according to the airflow density. Throttle position sensor. The sensor is used to monitor the throttle position of a car. The sensor moves with the throttle and sends a voltage signal to the computer indicating throttle angle and speed of movement. The computer uses this data to measure engine load, adjust timing, fuel delivery, etc. Temperature sensor. Temperature sensors include analog and digital sensor ICs designed for temperature monitoring of a system. Oxygen sensor. It measures the proportion of oxygen to fuel in the engine. The idle air control valve. It's also known as idle speed control valve. Regulates the idle speed of the engine. MAP sensor. This sensor measures air pressure, which shows engines the current altitude of a vehicle. NOx sensor. The NOx sensor detects engine knock and sends a voltage signal to the engine, and the engine uses that signal to control the timing. Engine speed sensor. An engine speed sensor is attached to crankshaft of car's engine, and it indicates the speed that the crankshaft is spinning with. This information is beneficial to control both the ignition timing and EMS. Engine oil sensor. It measures the oil pressure inside the engine and gives an alert in case of any problem with oil pressure. Crankshaft sensor. It is used to monitor the position and rotational speed of crankshaft, and this information will be used by the EMS to control the ignition system timing and other engine parameters. Camshaft sensor. The camshaft sensors determine which cylinder is firing to establish injector synchronization and coil firing sequence in DIS systems. Then the crankshaft sensor set ignition timing, supply the RPM signal, and measure the engine speed. Multi-point fuel injection. In EMS, each cylinder has a number of injectors to spray fuel in the cylinders as compared to one injector located centrally to spray fuel in case of single-point injection system. Through the use of MPFI, you will find more uniform air-fuel mixture supplied to all cylinders in your engine, and this uniformity of air-fuel improves the mileage of the vehicle. Thank you for watching the video.
Okay, guys, next is the onboard diagnostics. So this is one of the essential for the longer term operation in any kind of automotive vehicles and system in order to produce a clean exhaust. And any fault detected, it will be indicated to the driver by a warning light. Because then dashboard we can able to see the many of the sensor functioning and many other things in dashboard. For example, if you are not wearing a seat belts, the indicator will show you in the dashboard, and whether you are going to unlock your handbrake or remove your handbrake. If you are going to start your vehicle and move your vehicle, the alarm will be indicating, as well as the symbol is going to indicate in the dashboard. Like many things is going to display in the dashboard. Onboard diagnostic system is very much important, and it will be alert the driver to reduce the problems immediately. In case, for example, engine is overheated, immediately the signal is going to happen in the on dashboard. Because some of the major issues is going to be displayed in a dashboard immediately to stop the problems. And you just see this picture, you can able to see the from the engine. Okay, I will show you. So this is the engine. Okay, here we have a temperature sensor. Okay, the engine temperature is going to monitor. In case the engine temperature is very high, so this will, because this is always give some this will always monitor and give signals to the ECU. Okay, then ECU will tell this problem to the actuator, then actuator is going to reduce the problem. So this is the engine temperature sensor. Similarly, here we are having a phase sensor and ignition coil sensor and fuel pressure controller, and here we are having a NOx sensor, and then here we have a lambda sensor and exhaust valve. Okay, this is airflow, air mass flow, air is going to enter, and then both air and fuel is going to mix together, then it will send into the cylinder. Okay, for example, in some of the olden days method, both air and fuel is going to mix in a carburetor and it will send to the engine combustion chamber. But nowadays we are having a fuel injector. The fuel injector will be helpful to inject the fuel at the time of suction, and both air and fuel is going to mix it to this area, and that is passed to the combustion chamber when the inlet valve is going to get opened. Okay, similarly, the lot of here also we are using an electrical pump. This will also give some signals, and differential pressure sensor we have, throttle valve potentiometer, idly running adjuster. So the n number of sensor is going to connected with this electronic control unit. So this electronic control unit is one of the important, and this is all the data is going to be collected with a number of wires to this electronic control unit, and in case any wrong data, so this will give some signals to the actuators to correct it. So this is what happened. So this is the next video is the two-wheeler engine management system. நீங்கள் எல்லாமே வந்து பார்த்தீங்க அப்படின்னா 3-wheeler 4-wheeler தான் பார்த்துருப்பீங்க இதுக்கு முன்னாடி பார்த்தது எல்லாமே. இப்போ வந்து பார்த்தீங்கன்னா பாஷ் வந்து ஒரு 2-wheeler engine management system வந்து பற்றி சொல்லியிருக்காங்க. இது வந்து இன்ட்ரெஸ்டிங்காக இருக்கு பாருங்க.
Sporty and comfortable, but also clean, safe, and economical, Bosch is energizing the two-wheeler powertrain. Engine management systems are replacing outdated carburetor technology and now offer a solution to rising fuel costs and increasing traffic congestion, especially in Asia and South America. Bosch engine management systems, tailor-made with a passion for motorcycles. From affordable two-wheelers for mass mobility to high-performance bikes. Bosch offers a comprehensive portfolio of EMS technology for fuel injection and supply, air management, ignition, exhaust gas treatment, and engine management. The basic system for motor scooters and light motorcycles with air-cooled single-cylinder engines consists of the following components. The core component is the electronic engine management, which is the central control unit for the fuel injection system. The electronic control unit processes the information from sensors, such as the throttle position sensor and the temperature sensor. This allows it to control all system functions, such as fuel supply and ignition, to ensure a clean, economical combustion process in the engine cylinders. The electric fuel pump and pressure regulator ensure that fuel passes from the tank all the way to the fuel injector. The canister purge valve prevents evaporated fuel from escaping from the tank into the environment. Fumes instead pass into the intake manifold. The mechanical throttle body assembly enables the rider to precisely configure the air supply. The throttle position sensor measures the angle of the throttle valve, which allows the filling quantity to be determined. The electronically controlled fuel injector has several ultra-precisely manufactured orifices that achieve precise dosing and fine atomization of the fuel. The air-fuel mixture is processed within the intake manifold and fed into the cylinder for combustion. Inside the combustion chamber, the spark plug ignites the air-fuel mixture. The ignition coil supplies the required high voltage. The engine management system uses the crankshaft speed sensor, which registers the speed and position of the crankshaft to control the timing of injection and ignition. The Lambda sensor supplies the electronic control unit with important information for regulating the air-fuel ratio within the combustion chamber, allowing efficient exhaust gas treatment to be achieved. For high-performance motorcycles with water cooling, Bosch offers an electronic throttle body with a contactless angular position sensor for position feedback. This allows the engine management system to directly influence the air supply, enabling, for example, additional safety functions or performance adaptations to be realized. A manifold air pressure and temperature sensor in the intake manifold measures the air pressure and the air temperature to calculate the exact air mass entering the engine cylinder. This allows the air-fuel ratio to be controlled with even greater precision. For improved cold start behavior as well as better engine cooling and protection, an additional temperature sensor is installed in the cooling water circuit. A NOx sensor provides information about combustion, which is used to optimize the ignition point. This is how the best possible performance for every fuel quality can be achieved. A camshaft speed sensor registers the engine's power cycle, which makes it possible to configure the injection and ignition accordingly. Bosch also offers all individual components as integrated EMS complete solutions. Bosch works together in close partnership with motorcycle manufacturers to develop tailor-made EMS solutions for every type of two-wheeler. With a local presence in Asia, Europe, and the Americas, Bosch is familiar with the specific requirements of each two-wheeler market worldwide and offers a broad portfolio of EMS components in proven Bosch quality. Bosch applies the extensive knowledge and experience it has gained in the automotive industry to Bosch EMS technology for two-wheelers. As a systems provider, Bosch knows exactly what is demanded of each of the various components and how to combine them into a functioning whole. Bosch will continue to use its innovative power in the future to advance the development of drive technology for two-wheelers.
Bosch, invented for life.
Okay, guys, I think today you have a better understanding of the engine management system and ECU in automotive vehicles like cars and bikes. I think in video you have better understanding of the each and every parts, how the parts will be look like and how it is working. I think it is very much useful for you all the videos for your better understanding. Okay, guys. If you have any doubt in that area, you can ask. Anybody have a doubt? You guys, thank you for your presence and the entire time. So we'll meet in the next class.
Thanks.